Hi everyone. In this video, we're going to cover the point-by-point method of lighting calculations. And this method is used to determine the illuminance level for a specific focal point or from a specific luminaire. It's good for accent lighting and some tasks. This method can be really complex if you are using it for multiple luminaires in a variety of areas because they all interact, all right? And therefore, most lighting professionals will use a lighting software package for these calculations. All right, we're going to simplify in this course and take a look at a couple of examples with one light source and one focal area. There's two main ways that we use the point-by-point method. One is to solve for an illuminance level, and that will determine how much light is actually being provided by a given lighting design. If you've already designed it and you're just double checking, is this giving me the right amount of light? Okay. The other way, and this is a little bit more common, is to solve for the candela needed. So in this way, we determine what your target amount of candela are, how much you need, and then you can select a fixture to meet that need. All right. In both cases, we're going to use a formula that says the illuminance is equal to the candela value divided by the distance in feet squared. And the equation looks like this: E equals lowercase l divided by d squared. What is that distance? Well, it's the distance between the light source and the focal area. So you're going to imagine yourself stretching a string, perhaps, from the object that you're trying to light, or maybe the surface, the piece of artwork, all right, to the fixture itself, all right, and that would be your distance. The illumination is going to decrease, all right, the light level goes down the farther your surface is away from the light source, all right, and this is pretty easy to understand. The further you move your object away from the light, all right, the dimmer it is. And this follows the inverse square law. The drop in light level is going to be related to the square of the distance from the light surface. All right, and that's why in our equation it's d squared. So let's go ahead and give this a try and find out how much light is being provided with a given lighting design. We're going to solve for illuminance level using the point-by-point method. Here's our design scenario. All right, an accent luminaire is recessed into a 10-foot ceiling. It's shining directly above a plate. All right, that's our focal object. It's sitting on a table 3 feet above the floor. All right, if that luminaire has a center beam candle power of 10,000 candelas, okay, what is the illuminance level at the plate? Let's go ahead and pause right here and see if you can do this calculation. All right, are you ready? Time's up. Here we go. So the candela value for our luminaire was 10,000. And the distance was 10 feet minus 3 feet is 7 feet. All right, remember we're stretching an imaginary string from our focal object up to our luminaire. All right, and therefore the illuminance value is going to be 10,000 divided by 7 squared, and we solve for 204 foot candles. Let's double check. Is this design going to give visual interest to your art object? I'm not really sure. Let's find out. All right. The first thing we need to know is your target ambient illuminance level in the room. All right. For a museum space, the IES recommendation is somewhere between 30 to 50 foot candles. Well, as a designer, I actually want this room to be fairly dim, so I'm going to select the lower end of that and choose 30 foot candles for my ambient illumination in the room. All right. Therefore, what's my target illuminance for an art object? Use the 2 to 5 times contrast rule, and we find out that we want somewhere between 60 to 150 foot candles to really make this item stand out. All right. 204. Okay, that was what we were providing. That's actually about 6 times contrast to our 30-foot candle room, and it's a little high. All right, it's within reason. It's not going to totally glare out your observer. All right, but it's on the high end. One thing I really want you to note, that 204 illuminance level, it's only right in the bright center beam of your luminaire, all right? The center of the pool of light on that object. It's not going to be for the whole rest of the room. Now, more often, we're going to go the other direction, all right, and find out what candela value you actually need, and then select the luminaire that can give you that candela value. All right, so let's try this from the other direction. In our scenario here, we have an accent luminaire. It's recessed into that same 10-foot ceiling above the same plate that's on the same table 3 foot off the floor. All right, but we've already determined we want to illuminate that plate to 150 foot candles, not 204. All right, 150 foot candles. So what kind of candle power are we going to need from this luminaire? Go ahead and pause your video, pull out your calculator, and see if you can do this calculation. Okay, well, let's try it together. In this case, we're going to start with our calculation, our formula, excuse me, of illuminance equals candela divided by distance squared. But we're actually going to solve for the candela, the L value. All right, so the candle power is equal to illuminance multiplied by distance squared. In this case, 150 foot candles is our target illuminance. Multiply that by our distance of 7 feet squared, and we end up with a target candle power of 7,350 candela. All right, so we use that information, all right, to choose a luminaire that meets this criteria. Thank you, everyone. In this video, we just covered the point-by-point method of lighting calculations and walked you through a couple of examples of how to use these calculations in your lighting design practice.